Hello, my name is Todd Gooch. I'm the author of the Gravitational Unit Theory, Unified Field Theory. Today we're going to review Gooch Structures B. Gooch Structures B was a milestone in the theory. It really took it to the next level because now you could do chemistry with the work in real time. Takes a little longer to draw the structures still, but at least you're getting the right stuff. So here's hydrogen. We're going to go with hydrogen first. We're going to show you that it's got a key and it's got a keyhole. There's no bonding pairs and all that type of thing. There's no molecular orbital theory. There is no hybridization. And this is supported by hard data that there is actually two bonding sites on hydrogen in the cycloboranes. There's just no question about it. It was experimentally determined. So we start with hydrogen, got a key and a keyhole. Now we're going to draw methane. Now, draw hydrogen on the methane, on the carbon atom of the methane. After you get the initial structure drawn, and then you add the hydrogens. I like to draw them one element at a time. And there's methane. Now you can get 3D representations of these molecules, show the tetrahedral arrangement on the carbon with colored pens and pencils, but today we're just gonna just kind of go on with what you can do with a regular pen. Now, if we wanted to do ethane, of course, it's the components start to become important. Petroleum chemistry, organic chemistry. It's just amazing what you can do with the structures. But you can represent any structure that the standard model can represent with Gooch Structures B, except you're representing them much better and much more detail than Lewis structures could ever think about doing. When you start doing the reactions with them, you find that the detail in the reaction is just like having it's just like having a camera down in solution, and that is been the ultimate goal of chemistry since the beginning of chemistry. And then what I'll end with is benzene. I'll go ahead and do benzene for you. I like to get the structure of benzene first. There's your carbon atoms. And you go ahead and connect the carbon atoms. It's easy to keep the arrows straight. They all follow the same pattern. There's no problem there. You just want to go ahead and get the general structure down for benzene. Except benzene has 1.5 bonds. These are all single bonds here. So we want to make that a 1.5 bond. The carbon atoms. Been a while since I drew it. But I think it's good to illustrate that we go from a single bond to a 1.5 bond. And that's how the structures are better than Lewis structures because they're able to represent the 1.5 bond here for the equal energies on each of the carbon atoms bonds to each other. And here we go to make the bonds for the hydrogens. This so. Trick is not to put the arrow in the wrong place. Wow. It would mess the drawing up and you got to start all over again. Not really a fan of doing that. I like my artwork to go real smoothly. Flow. And molecular orbital theory was born over this molecule right here, because it could not resolve the structure with Lewis structures alone. They had to start to use molecular orbital theory, and it was all over this molecule right here, which I can represent with these structures without ever having to go into another theory or use different structures. And this is why Gooch structures B is better than Lewis structures. There's no doubt about it. My name's Todd Gooch. My theory is gravitational unit theory, unified field theory. I'll be giving the theory of everything at the end of this video series, and I encourage you all to look forward to it because I will be doing all four forces with a single equation. And thank you very much for your time.